this section, you're going to get two sets of formulas. The first set is for theta in, what will theta be in for these first formulas? Degrees. So these formulas are when you're dealing with theta in degrees. You have arc length, two formulas. They're really the same formula reduced. So S is equal to theta over 360. It's a fraction of the circumference, 2 pi r. So theta over 360 times 2 times pi times r, or pi times diameter. If you reduce the 2 pi r with the 180, or the 360, the 2 and the 360 would give you theta pi r over 180. It's the same formula. I don't really care what you use. And then a sector, remember a sector is like a piece of pizza or a piece of pie. It's bound by two radiuses, or two radii, and an arc, included arc. Its sector area will be the fraction of the area of the circle. So theta over 360 pi r squared. Remember, those formulas, you can only use them when you're in degrees. These formulas are only for theta in degrees. Remember, little, yes.
On the area of the sector, is it like theta over 360 times pi r squared, or is it pi r squared?
No, it doesn't matter whether it's on the top, it's still pi. It's a fraction times, this looks like that because Mr. Moore did this in this program right here. This program, the notebook program, you should use math type. That's just out of correct.
Alright. Thanks.
Alright, so those are your formulas. S for arc length, K for sector area. See if you can find the arc length and area of this sector. And again, some of you are like me. First thing I would do is draw the picture. Yeah. Sector of a circle has a radius 20 and a central angle is 215. So this is 20 centimeters, 20 centimeters, and this angle right here is 215 degrees, and this is the sector you're dealing with. Let's see if you can figure out what's what here. Yeah, answers? Please. Stephen, what'd you do for arc length?
I got 215 pi over 9.
Okay, what formula did you use?
I used S equals theta pi r over 8.
And what'd you plug in?
Plugged in 215 for theta and 20 for r.
And so your arc length ended up being, what was it?
215 pi over 9.
215. Okay, and that would be centimeters, right?
Yes.
Make sure you have your labels. And know that you think I'm not going to mark you down, but you're going to lose points on every single one. It'll be painful at first, but you will then start doing labels. Don't be that person who gets marked down on every single answer. Area of a sector. That's what you get for that. Good, what are you doing? K equals?
Theta over 360 pi r squared.
What you plugging in?
215 over 360 multiplied by pi times the 4.
Okay, so 20 squared. So 215 percent 360 pi times 20. when you reduce, we don't get that yet? (21) over 9 centimeters squared. Is everybody following those formulas here? Sectors and arc lengths are fractions of circumference and area. Sector area and arc length are fractions of the whole circle. The area or circumference formula. These formulas are for theta, not in degrees, for theta in radians. One of the frustrating things is to watch people who don't learn their formulas interchange them with degrees and radians. They don't interchange. So theta in radians for these formulas. Arc length, we did that yesterday, S equals arc theta. Excuse me. Area of the sector, two formulas here. Again, both the same formula depending upon what you're given. 1/2 r squared theta, bless you. Or 1/2 rs will also give you sector area. If you realize r squared can be written as r times r. If you took one of the r's in the theta in the product and replaced it with s, that's where the 1/2 rs comes from. So these two formulas are just variations on the same formula. It's easier to work in radians than it is to work in degrees. The formulas are easy. Get these, Brian? Yeah. Everybody got these? Okay, so same drill. Arc length and sector area. This time, when you know the radius is 34 feet and the central angle is 2/3 pi. How do you know that this is 2/3 pi and that you're in radians? Yeah, there's no degree symbol. It's not the pi that makes it radians. It's the fact that there's no degree symbol. So again, drawing a picture can help. 2/3 pi, where's that arc going to end? What are you talking about? Oh, because you. Where do I stop the arc? Somewhere in here. Okay, don't go to half. It's something less than, all you need to know, it's more than a quarter, less than a half. Anywhere in here gives you the visual that you need. 2/3 of a pi is less than pi. And pi is halfway around. Okay, so this is 2 pi over 3, that's your central angle. And your radius was 34 feet. So this is the sector you're talking about. Most? Well, so we'll start with our map. What you do for our okay, this map.
2/3 pi times 34.
What formula are we using?
Equals theta r.
So r theta. So what'd you say? 34 and 2/3 pi. So what'd you end up with?
68/3.
So S 68/3 pi. No? Everybody all right with that? County? Area? formula did you use?
The one radius
Square times theta. Okay, so 1/2 34 squared, and any questions for those? This is plug and chug stuff. You got to know which formula. You got to know whether you're radians or degrees. But after that, it's plug and chug. Okay. So now we're going the other way. Now I'm telling you, here's the arc length, here's the sector area. You tell me what the radius is, and you tell me what the central angle is. So see what you can do on finding those. At least one, had to like the pain and suffering way to do it. Anyone do that? Come on now. Who did it using the degree formulas? Nobody? Smart class, that's right. Because that degree stuff, that is serious pain and suffering. You end up having to solve a system, I think, on that. You don't want to go there. Kevin, what'd you do for radius?
For radius, I did 75 equals 1/2 r times 6.
And what formula are you using?
That's an area of the sector radius.
K equals 1/2 r times s. You're plugging in the area, the arc length, and you're solving for r.
Yes.
And what did you find out?
That r equals 25 or
25. So 25 centimeters. Right? If r is 25, Kyle, what did you do for central angle?
Central angle. Just do the arc length divided by radius.
So s equals r theta. We can plug in 6 for s, and now we know what r is. Like you said, just 6 over 25 is equal to theta. And then Kelly said, well, can that be right because it doesn't have a pipe? Of course, it can be right, because when you talk about this, this is pi over 2, this is 3 pi over 2, and this is 2 pi or 0. It's like it's a unit of measure. Okay, these are units of measure. From 0 to pi over 2, somewhere between 0 and pi over 2, you should have the number 1, right? You would expect that. You would expect. Really? You would expect if you pull a ruler out and you're measuring, this is 1 inch, 2 inch, 3 inch, 4 inch, you could put on the ruler, right here, you could put pi inches. Nobody does, but it's there. Oh, look, it was pi inches long, Mom. Never going to happen. Okay? But just like we get so used to seeing pi in our radians, just because there isn't, it's okay. We know it's radians because there's no degrees. Okay, apparent size. Apparent size is not exact, but it's a pretty good ballpark. When we have something that's pretty far away, we can use this idea of apparent size to figure out how big something is. And in this case, we're going to talk about the diameter of a planet or an object. what we're going to do is we're going to make when you're the person looking, we're going to make your eyes the center of the circle. And when you're sitting here looking up at the moon, if you drew to this side of the moon a segment, into this side of the moon a segment, between the edges here would be the dotted line would be the diameter of the moon. That's what we're trying to figure out. What we're going to do to figure that out is we're going to say, look, if this is a radius of a circle, and this is the radius of the circle, we're trying to find out the distance here. Well, what we can do is that we can say, look at the arc. What do you notice about the arc of this circle and the diameter of the moon? They're pretty close in length. And the bigger the distance, I mean, this is only a couple of feet right here. And it already looks like the arc length and the diameter are the same. If you go out hundreds of thousands of miles, believe me, that arc and that diameter are going to look virtually the same. They're going to be almost on top of each other. So what we're going to do is we're going to find the length of this arc and use that to describe the diameter. It's not exact, it's approximate, apparent size, right? And the longer your radii are, the more accurate you will be. There is a whole field of geometry, and I can't remember if it's Lobachevskian, Riemannian, it's one of these geometries where they said there's no such thing as a line that is straight. And there are no planes. They don't exist. Anytime you have a line, you're taking part of a circle. And that circle is so huge that when you're looking at it, you're saying, it's got to be straight. But the circle is so enormous, you're looking at just an itty-bitty piece of the circle on a small arc so that you're thinking that it's straight. Same thing with something you like the desktop. You say, oh, that's flat. It's not. It's part of a sphere. But the sphere is so enormous, like the Earth or bigger, then your tabletop looks flat. But it's really not. It's really slightly curved. And there's a whole geometry behind that where some of the angles in a triangle no longer 180. It can be more. You can have 2 right angles in a triangle, or 3. So what we're trying to do here is just take it to the extreme so that this diameter and this arc are virtually the same. Your formula for arc length is n over 180 pi r, or theta pi r over 180. So if we're in degrees, as in this problem, you have an apparent size of 0.01 degrees, that's theta. The radius, 8 times 10 to the 8 kilometers, and you're trying to figure out what's the diameter of Jupiter. Now, this is something you're going to go 3 decimal places on. So 0.01 over 180 times pi times the radius, which was 800 million kilometers. So you're going to want to get out your calculator and see if you can actually get the number here. You're going to press the pi button to figure out what that actual diameter is going to be. So the apparent size is what we're looking for. And remember, the apparent size is the angle that comes from your eyeballs to both sides of Jupiter in this case.
Would the other arc length that they for?
It would, but you would have to convert to radians.
No, I was just referring to the other variant. The theta over 360 times.
Oh yeah, that's the same formula. Theta over 360 times 2 pi r is the same formula. You just didn't reduce the 2 and the 180. The 2 and the 360.
Alright, and I think that's going to my second question. Are we going to be given a problem where it's going to be a
Sure. been easier though. Andy, what'd you get? 3,4, so 340. That would be kilometers. We're 39,626 kilometers. It's not exact. Is it? Right? Any questions here? Yeah. No, 3 decimal places. You mean like here? Yeah. No, I want 3 decimal places. Okay. We did this problem 2 different ways, although I've never done, somebody else did it last period a different way. Doesn't matter to me which way you do this, but I want you to figure out, let's say you go through and you hit a piece of gum, and you ride for a minute, right? Or no, we're going to do, 1 minute. So if you go for a minute, I want to know how far that gum is going to travel. That's the total distance the gum will travel. Okay. 1 minute. Jared, what'd you do? Boy, good effort.
I tried to look and tried to fix
You
it.
tried to look?
I looked and I
Tried to write some things down? Any chance you could tell me how far the gum went around? How far the gum went in one time around? How far? Yeah, we want distance. You're absolutely right. It is 360 degrees. It's also 2 pi radians, but that's not a distance. Any idea how you would figure that out? Hey, this is where I need that electric shock thing. I want it in the chair, because that's the, so I would just press, the seat button, like I'm going to, we can put the collar on.
Force it.
If it's in the chair, I don't have to force it.
You don't have a choice.
I wouldn't sit in the chair then.
Really?
I'd swap with my neighbors, and then be more disruptive. So
How far did it travel in one revolution? It's called circumference, right?
wow. It makes it sound smarter.
It does, especially this problem with the tire looks so confusing. And this problem right here,
Yeah, it was.
yeah.
It's not the.
is it the nose?
Yeah, that's There's not even straps on the helmet.
I know, what's the point? As soon as it gets hit by the car, the helmet's going flying.
Where is it?
It's the head.
I would be much more concerned with the fact that he doesn't have any spokes.
Or the fact that there's no
The real set.
Maybe it's a box or you have brakes. This box could be great.
Yeah. So, 24 pi inches one time around. Okay? How many times around is this piece of gum going? 33 times. So we're going to multiply that by 33. And your distance is going to equal what? A lotto's coming soon. I'm sure you should play.
Now I get it.
Yeah, there's, how many formulas do we have? 6. Oh my gosh. Put them on a note card, and then you don't have to even learn them.
You think the note card on the test?
If you put them on the note card now, I guarantee you,
We just got.
Hey,
I guarantee you won't need the note card on the day of the test.
everyone, can you just have it then?
Absolutely, right up until I say clear your desk.
So funny.
Do the problem. Remy, were you able to solve for us?
I don't know how to do it.
Yes, you do know how to do it. Look at this equation. I want you to solve for S.
S equals P minus 2R.
Are you okay?
Yeah.
Not in any pain, right? Don't make it complicated if it's not complicated. The directions, I think, are confusing. Anytime I see solve in terms of, write a function in terms of, that terminology gets to be a little bit confusing. So if you're writing an equation for the arc length, that's what they're asking you to have. So it's got to be arc length equals. So as a function, what are we going to put in for P? 76 minus 2R. That's not an R. That's all you need. Okay? Another good website, coolmath.com. They have some great printable things that you may need in the next couple of months. So this, if you go to their trig section, some of the stuff I've already stolen and we'll post for you, but they have a lot of good stuff there when you're struggling with the trig. The site from yesterday and this one, pretty good. This is your assignment. You ought to be able to knock off most of it before you go. If you need help, you're coming to me. I moved him over with the Santa and the whip.
Yeah, I think the chicks broke the
They were both rocking yesterday. If all the lights are on, they both get after it. Except you broke the bunny.
The bunny's dancing faster than the chick.
Yeah, it's still
The
not
chick
working.
barely
Look at
moves.
Santa. And the witch.
Who broke the chick then? I think
The
I
chick just needs
broke that.
more
You're
light.
blaming it on
The
me.
amount of gold that
You
you
know,
lifted towards the chicken
when
made
did
its
you
way
learn
into
not
its
to take
crack.
responsibility for
I know,
yourself?
like,
I didn't break
Bunny,
it.
like,
Uh-huh.
stops. The chick
You didn't know
barely
break
moves. It's moving, but it's like,
When you do that person, it's not fun, let's play attention.
like, how are so fast they evolve? I'm not sure. It's the green one.
That's a witch from Halloween. It's kind of a scary looking
So they all represent all
Like
holidays.
scary in a weird way.
Wait, where's the witch?
Flower could be
Next to Santa.
They all
Oh, I
represent
thought it was the